7.5, lesson part 2, conjugates, which is kind of an extension of dealing with division of radical expressions and rationalize the denominator. Now, for example 1, I have 2 over the square root of 5 minus 4. If I try to multiply the top and bottom by the square root of 5, yes, I'll lose the first radical, but when I have 4 times the square root of 5, I still have a square root. I need some way that I can square both of the terms on the bottom and not end up with any other radicals. So just square them and have nothing else. Well, if you remember the stuff from Math 101, or you remember your earlier algebra class, what I'm going to multiply by is, or what I'm going to try to do is get the difference of square patterns. In other words, the square root of 5 plus 4. So when I multiply the bottoms together, I'm going to get square root of 5 times the square root of 5, which is just 5. 4 times negative 4, which is just minus 16. But then I have positive 4 and negative 4 times root 5, which cancels out. In other words, no middle term. Now on the top I just have 2 times the stuff, so it's 2 root 5 plus 8. Think about it, distributing in. Now, 5 minus 16 is 11, so I have 2 root 5 plus 8 over 11. Alright, let's do the next one, and I'll do the next one a little bit slower and kind of explain a little bit more. So example 2 is negative 6 over the square root of y plus 3. If I try to multiply the square root of y plus 3 times the square root of y plus 3, I would end up with a middle term. So if I look at the box method of root y plus 3 and root y plus 3, I end up with y, 3 root y, 3 root y, and 9. If I combine my middle terms, I end up with 6 root y. In other words, I still have a radical on the bottom. So instead what I do is, I take my square root of y plus 3 and I multiply by something which is called the conjugate. Now the conjugate is the same, except whatever sign was in the middle, if it's plus becomes minus, if it's minus it becomes plus. Now the conjugate is a fancy way of saying that it's paired off. Now, when I do my box method for this, right, when I do the multiplication, I have the square root of y plus 3, square root of y minus 3. Y times y, or root y times root y is y. 3 times root y is 3 root y. Negative 3 times root y is negative 3 root y, and 3 times negative 3 is negative 9. This time, my middle terms, the 3 root y and the negative 3 root y, they cancel. So I'm left with, on the bottom, y minus 9. In other words, the first term squared, so root y times root y is just y, and the last thing squared, 3 times 3 is 9, and then it's always going to be minus. And on the top, I have the negative 6 times all that stuff, in other words, negative 6 root y, negative 6 times negative 3 is plus 18. Alright, I got one more example, and I'm going to do this one a little bit quicker because this is where I want you to eventually be. And it's not that quick, even though I say that. I have radicals on the bottom. I don't want radicals on the bottom. In order to get rid of radicals by the bottom, I'm going to multiply the top and the bottom of my fraction by the conjugate of the bottom, which is a fancy way of saying multiply by the exact same thing, except change the addition to the subtraction or the subtraction to the addition. Now, without even thinking about it, I know that the bottoms are going to become 3 minus 2 because I squared these and I don't have a middle term. See previous example. The top, on the other hand, is a little bit more unsettling. I'm going to have to do the box method for this, and I think I have a little bit of space here. Now, I didn't leave myself a lot of room. I'm hoping when you're doing your scratch work, you do. Keeping this neat and organized is going to help you with a lot of those little goof-ups. Root 3 times root 2 is root 6. Root 3 times the square root of 4 is root 12, which I'll simplify in a minute to be 2 root 3. Root 2 times root 2 cancels, so I just end up with negative 2. And negative root 2 times 4 is going to be negative root 8, which is equal to negative 2 root 2. Again, I'm going faster because I know the pieces. Do it out with a lot of space so you can see what each of the things is. Now, I don't have any like terms. I have root 6, no root 6s. I have root 3, no root 3s. I have the number 2, no other neg 2s. I have a root 2, none others of those. So, in the end, I end up with root 6 plus 2 root 3 minus 2 root 2. And then my bottom can be cleaned up, and my final end result, and I know it's not pretty, root 6 plus 2 root 3 minus 2 root 2, all divided by 1, and I'm not going to rewrite it again. That's what you get when you try to rationalize that denominator for example 3. Sorry for the length of this video. If you got questions, please email them to me and try to take a screenshot from Canvas when you do that.